comes down to computers communicating.
The information superhighway can be a confusing mix of on-ramps and off-ramps.
Bitcoin is worthless artificial gold.
Is it still rat poison?
Probably rat poison squared.
We need to get into the world of, okay, this is actually foundational technology.
What the Internet of Money does is it creates a single network which can do a microtransaction to a gigatransaction.
The Internet is going to be one of the major forces for reducing the role of government. The one thing that's missing, but that will soon be developed, is a reliable e-cash.
Thank you for joining us for this week's episode of Final Settlement, a podcast from Onramp Media. On today's show, we're joined by Ryan MacLeod, a chemical technologist and Bitcoin enthusiast who works in the nuclear industry. We discuss the potential of nuclear power, the utility of Bitcoin mining, and the synergistic relationship between the two industries. Ryan explains the challenges and misconceptions surrounding nuclear power, including cost and safety concerns, highlighting the benefits of small modular reactors, which can be factory built and commissioned in shorter timeframes. The conversation touches on the global interest in nuclear power and the technological competition between different countries. We explore how Bitcoin mining can complement the build-out of nuclear power plants and contribute to energy independence. Nuclear power provides a reliable and efficient source of energy, while Bitcoin mining offers a way to utilize excess energy and bootstrap the build-out of energy capacity. The integration of Bitcoin mining with nuclear power can create a more stable and resilient grid, providing a path towards energy independence and an abundant future. And now, time for the show. And we're live. Welcome back to Final Settlement. Very excited for this week's episode. On the show today, we have Ryan MacLeod, who is a chemical technologist by trade, and for the past decade or so has worked at Canadian Nuclear Laboratories. And he also happens to be a Bitcoiner. But the reason I'm really excited for this convo is because, thinking about sort of the purpose of this podcast in many ways is to show Bitcoin as a technology, as a protocol that people are leveraging in the real world and using for various forms of utility. And one thing that we haven't really touched on thus far throughout the episodes is the Bitcoin mining space, and why that is really, in my mind, one of the greatest examples of Bitcoin's utility in the real world, in the sense that, we now as a human species have the ability to monetize energy in a location agnostic way, which was never previously possible. And I think that itself is a form of utility for Bitcoin mining that is completely outside the realm of price or number go up or, the digital gold thesis, if you will. And so very excited to talk not only about Bitcoin mining, but about the nuclear space, which Ryan is a domain expert on. And so welcome to the show, Ryan. Glad to have you.
Thanks for the introduction, Brian. I certainly wouldn't call myself too much of an expert. Just like with Bitcoin, this is an endless rabbit hole, and you can immerse yourself in it for as long as you want, and you will never see the end of it. I am lucky in my position that I have exposure to many nuclear scientists, so I can always pick their brains on many of these topics. And my interest is predominantly on the economic side of these things. Like we've got many great scientists trying to solve all of the new challenges with fuels and materials and getting the SMRs to commercial stage, and also supporting the existing reactor fleet. Like Canada's got, where I'm from in Ontario, we have 20 operating nuclear reactors at 3 sites, and that provides 60% of the power for the entire province of Ontario. And we often export a lot of that to the states in the Northeast Corridor, along with Quebec often. But mining is really what got me attracted to Bitcoin in the first place. Like, I was already kind of primed to understand Bitcoin. Like, I'd watched the Zeitgeist movies back in the day. I was following with Ron Paul and the End the Fed movement. Max Kaiser came up every once in a while in the alternative media that I was paying attention to at the time, and then never pulled the trigger. And then years later, I cashed out some Bitcoin from an online poker site. And then it was 21. The run up in Christmas 21 that was really grabbed my attention. And then I quickly went off the deep end with Max's podcast. And then it was when I was introduced to Steve Barber and Adam O, did 2 consecutive podcasts around them at that time, talking about what they're doing with stranded power. And then that just got me really interested in mining. I'm telling my wife all about it, and it's like, oh, that's great. You found a new hobby. That's very interesting. Like, hopefully you can find some friends to talk about it, because you talk about it a lot and it can get annoying. But then but it was good though, because I gave her enough of an education on this that when Elon Musk started crapping on Bitcoin's energy usage on the backside of that spring run up, she just threw out the idea of just, if the type of energy that Bitcoin mining is using is a problem, why don't we focus more attention on mining Bitcoin with nuclear power? And at the time, I was kind of paying attention. Like, I wasn't super immersed in it like I was now with like nuclear advocacy and learning everything I can about the industry, but I was aware that we had a plan to develop small modular reactors, that we're currently refurbishing our entire fleet to extend it well into the 60s, that around America, many of their reactors were being chosen to retire them instead of making the effort to try and refurbish them and extend their lives, like Indian Point, Palisades, Pilgrim, Vermont Yankee, San Onofre. And then they seemed to draw a line at Diablo Canyon in California, and that's where they kind of said, no more of these reactors being shut down. But around that time, me paying attention to Bitcoin, it seemed like whenever nuclear power got brought up in the context of Bitcoin mining, like at the conference or just the mining panels or whatever, it was always with the perspective that nuclear's kind of on its downturn, the reactors are being shut down, there's not anything invigorating the industry. And then all of the sudden, world events started to happen, and now all eyes are on nuclear over the last 2 or 3 years, and everybody is very aggressively looking at it as a critical piece of the infrastructure architecture for like many nations to secure their energy futures, because it's a superior form of energy generation. It takes a lot of capital to pull it off, and it takes a lot of alignment across a lot of stakeholders. But when it is operational, it provides so much value to the countries that host it, that they can see massive increases in their GDP from using it. And then you can see countries that have had strange relationships with nuclear power, like Germany's an interesting one, retiring their fleet. Meanwhile, the accident happened in Japan, and Japan is now actively trying to return their fleet to service as fast as they possibly can, because the cost of importing natural gas is killing their population, and it's not a fun experience for an aging demographic when they have to start choosing between rent and heat and food when in these trying times. Especially you guys are familiar with the financial situation over there. Like, their currency is a complete basket case, so it's going to be interesting to see how they can pull this off. But I would actually like to see more about there was talk that somebody in TEPCO, Tokyo Electric Power Company, was investigating Bitcoin mining. So I haven't seen anything else about that since then. There was just like one like little news report about 2 years ago, but I don't know, maybe something's bubbling behind the scenes.
At Onramp, we believe that Bitcoin will be the most important asset to own in the 21st century. Our multi-institution custody solution is the safest and most secure way to ensure that your Bitcoin remains in your and your family's possession for decades to come. Multi-institution custody maximizes security and minimizes counterparty risk, leveraging Bitcoin's native properties to eliminate single points of failure that have historically complicated Bitcoin ownership. Onramp provides peace of mind for your Bitcoin journey. For more information, check us out at onrampbitcoin.com.
You brought up a lot of good points in there. I think one, for me, it's been very interesting to sort of observe nuclear from afar over the past few years. And to your point, I think the Overton window is shifting a little bit with respect to recognizing that this is, a viable path towards creating energy independence. And the notion of energy independence has become more and more of a hot button issue as we've seen all the issues sort of with fossil fuels and having to rely on other countries for the vast majority of your energy. I think it's becoming more and more top of mind. But I think the reason why that's so interesting is because for so long it was, nuclear as a whole was sort of demonized, and for various reasons that I would love you to go through in terms of, why were we in a place prior to the past couple of years where people effectively dismiss this as not a viable solution? And I guess what has changed over the past couple of years that have, in your mind, opened people's eyes to the merits of a nuclear strategy?
Yeah, there's many factors that go into play to explain why nuclear's been having a tough go of things. Like bureaucracy is definitely one of them. There's very well-funded opposition to nuclear power, whether that's coming from like the oil and gas industry or like other competing industries that don't want to see as much nuclear power on the grid because it cuts into their market share, even though like you talk to a lot of people in these industries and they're very supportive of like, yeah, we need the power, but the incentives and how all of these interests financially interact starts to create interesting feedback that results in nuclear power getting demonized disproportionately to compared to other technologies. And there's a lot of scrutiny. Like radiation, it is an industrial hazard, like many other industrial hazards. Like we know how to handle it. We know how to safely manage fuel and radiation products. But because of that, like radiation is a contentious topic in the public. Many people raised watching Simpsons are familiar with how they portray nuclear power, which is not the most accurate depiction. There's like many instances in popular media that they do not accurately portray it, and then it creates an anchoring bias in a lot of people's minds. And then there was also the fact that like the Cold War happened, so there's an entire generation of people that have that trauma to affect their decision making and their perspective on nuclear power. But there's a whole new generation that sees it as an opportunity to build for the future. So that is very, very refreshing to see that the youth are taking an interest in a technology that can be greatly beneficial to them, because especially since they don't get exposed to much nuclear power unless they actually seek it out in school. So much like when you're familiar with how many people go through an economics class and never learn anything about Austrian economics.
Yep.
Like you can go through entire environmentalist courses, entire like energy infrastructure courses, and you'll have like just a brief little talk about nuclear power and just be like, oh, it's there. But let's focus on windmills and solar panel because it's free when it's generating electricity. And like there's a whole host of reasons why I disagree with a lot of the assertion that we can power a high-tech society on wind and solar, and mostly has to do with like that it's very challenging to get power to where it needs to be when it needs to be there. That is where the costs of wind and solar start to ramp up. But if you just look at them standalone, they can look great if it's just a windmill in the middle of nowhere with batteries to back it up, and they can definitely look like they've got good economics. But as soon as you start having to tie that into the grid, things get a lot more complicated. And one of those reasons, something that I was reading up recently, it's inertia is an interesting concept on the grid that most people aren't familiar with. And it's provided by thousands and thousands of spinning machines synchronized at the exact same frequency. So that's the 60 hertz that most people hear about when someone's talking about the grid frequency that they try to maintain. So that's all of these spinning machines, whether it's your hydro generators, your coal plants, gas plants, nuclear power plants, they all spin at 60 hertz and they all synchronize with each other. And so if you're bringing new generation onto the grid, it has to synchronize with that 60 hertz. The type of electricity that's generated from the windmills and from solar panels doesn't synchronize with that. So then that's another added cost that they have to bring into this equation in order to like properly synchronize with the rest of the system. So then it creates this dynamic where some of their advocates are just like, well, if we just do away with the old system and we create a new system, we can create a better fit system. But it doesn't quite work like that when you're trying to adapt something that was built over many, many decades and is very, very complex, like a grid that serves like hundreds of millions of people, especially in North America. You can't just change it with a visionary new technology. It has to have a period of adaptation. And what is being seen a lot right now is as they more aggressively push these like non-synchronous generation sources onto the grid, they are seeing that the diminishing returns are like that would naturally be there aren't really manifesting because there is so much subsidies, so much tax credits, so much revenue that they can collect that is unrelated to actually selling power on the grid, that it starts creating a lot of distortions in the pricing market. So then it doesn't give proper signals to when new generation should be built. It just creates a lot of disruption in the markets, and it makes it very challenging for the engineers that are actually responsible for taking care of these systems and making sure that they operate in a reliable fashion. Is incredibly it's just an increasing challenge for them, which then just increases more costs. So it's
That was
rambled a little bit there.
No, that's helpful context. I'm curious if you could drill down a little bit more into the costs, right? Because I think there's general misconceptions around the costs of some of things like wind and solar because they have been heavily subsidized, to your point. So if in the absence of that, how would you sort of compare and contrast the costs of building out capacity in wind and solar versus building out capacity in nuclear? Because I would also imagine, and I would curious your insights on this as well, is like over the past few decades, like I would imagine the costs of building out nuclear capacity have also come down and improved, and technology has advanced in that sense that it is more realistic to build out this, much more efficient and dense version of energy capacity. So curious, any thoughts on just like, if in the absence of subsidies for wind and solar, like what would that sort of cost benefit analysis look like relative to something like nuclear?
Like, I wish it was the case that the cost of nuclear is coming down, and in some ways it kind of is, but the one big failure in the West was not sustaining the capabilities as well as they should have. So that's like Vogel is a pretty good example of trying to restart a program that was kind of allowed to atrophy. So like the US had lots of experience building nuclear reactors, and in my opinion, one of the flaws of that system is building bespoke reactors that don't all match with each other. Whereas like in Ontario and France, they just picked one reactor design and then just evolutions of that design. Whereas in the United States, you've got reactor sites where there's two different reactors on the same site. So you can't even take the same operator out of one reactor to operate the other one. Whereas you can take an operator out of a Bruce reactor and put him into a Darlington reactor, and it wouldn't even make a difference. They'd be like 90% up to speed, whereas it would be a considerably different situation in a US reactor. Like 3 Mile Island is a perfect example. They couldn't peel operators from the other reactors to respond to the issue that they were having in the one reactor that was having issues back in the 70s. But that's separate topic. But the thing about the cost of nuclear is it's so front loaded. There's the licensing, there's the engineering, everything gets packed up front. And then they also have to be able to account for their entire life cycle, like what they're going to do with the waste, what they're going to do with decommissioning. So a lot of the capital in building nuclear is very heavily front loaded. So then that makes it disproportionately more challenging for them to recover those capital costs in the same sort of time frame. So if investors just trying to turn around their capital within 5-10 years, and then you can just see like, well, we'll just build these windmills and solar panels, we'll take the production tax credits, just harvest those for 10 years, and then you move on to a new project. Whereas with nuclear, it requires a much longer time horizon, thinking in like multi-generational, like 40-year like periods that these systems are going to be operational. Like Canada, like our reactors full life will probably be about 80 to 90 years for the ones that we're refurbishing right now. So like we can get almost a century out of these things. It's basically the same idea of doing like a resto mod. Are you guys familiar with that concept where they take like an old car, replace all the old insides and give it new brakes, new transmission, new components. So it's basically on the outside it still looks like the same old machine, but on the inside it's got brand new, everything's been refreshed, and it should be able to remain operating for another 40 plus years if it's maintained well, which we have a very robust program here in Ontario that we take good care of these machines because they provide a lot of value to us. And we need to build more of them in order to drive those costs down. But like a lot of that comes to like the way that they're financed with subsidies and stuff, like because that creates all these distortions in the markets, because now that subsidies are a thing, everyone's competing for the subsidies instead of trying to compete for like actual market share, because that's basically what fiat has done to this entire system. It rewards those who are better at ingratiating themselves with politics rather than who can actually provide a better service to the market. Like, luckily, like we're seeing alignment in politics. Like Senator Granholm just came out the other day and saying that we need 98 more Vogels, which is like a very positive for the industry, but like that's also going to require a lot of capital. That's going to require a lot of alignment, and it's a very good thing for them to do that, because now that Vogel's been done, they've learned from the experience of building Vogel, which had a lot of trials and tribulations. If anyone wants to do a deep dive on that, the Decoupled podcast did a 4-part series that explains the whole Vogel saga from start to finish and all of the reasons why it was challenged, whether it's regulatory, bureaucracy, just trying to start a project without a finished plan, and then parts move on when things start moving, and then stakeholders start getting upset with each other because timelines aren't being met, and it got to be a bit of a mess. And like Westinghouse almost went bankrupt, and now they're partially owned by a uranium mining company, Cameco. That's one of our companies up here in Canada that provides a lot of high quality uranium for our fleet and for a lot of the American fleet. And they're planning on expanding our extraction capabilities for uranium, because there is clearly a lot of demand for it. So we are aggressively trying to ramp up our fuel production capabilities, especially now that Russia is being cut off from the rest of the world. So Russia was the primary enriched uranium provider for most of the world's fleet until 2 years ago. And so now everyone is frantically trying to recalibrate their fuel cycles so that we can produce as much as what we can in America and Europe and in Canada. But like, luckily in Canada, that is our unique feature of our reactors, is we don't actually need to enrich the fuel. We just have to refine it into the fuel rods, but the natural isotopic ratio that it's found in when it's extracted from the ground can be used in our reactors because of the way that we use heavy water, which is a unique feature that gives us an advantage that we can use our own fuel without having to rely on external parties. So we can have our entire cycle from cradle to grave contained within Canada. So that is one of the things that we proudly like to brag about every once in a while. But yeah, it's just learning from the mistakes, putting it into action, getting a supply chain and a labor force back in line, and getting more people interested in being a part of this technology. Like, we need laborers, we need engineers, we need tradespeople, we need management, we need salespeople, we need, like, more than anything, we need a lot of people that are really good at public communications, because that has been one of nuclear power's biggest challenges, is that the only time you ever hear about it is when something goes wrong. So
Right.
Public relations needs to be a lot more aggressive, getting the message, the pro-nuclear message out there, and all of the great things we can do beyond even just power generation. Like, because like we do tons of radioisotope research here at our site at Canadian Nuclear Labs for medical applications, for sterilization, for different agriculture applications. There's dozens of different isotopes that can only be created in the environment that a nuclear reactor provides. So it's there's a lot more to this industry than just generating power. So that makes an interesting argument when you do start getting into like what's superior an energy generating system, the nuclear or wind and solar or like all the other competitors. But it's not an even match, because nuclear, like, for one thing, the power density is so outrageously superior. And then the fact that there's all kinds of other peripheral things that nuclear power can do that wind and solar can't even touch. Mm-hmm. And then the other fact that you can just drop them, you can just replace a coal plant with a nuclear power plant, because the transmission infrastructure is better aligned for a large thermal plant, rather than building out large fields of hundreds of thousands of acres of windmills and solar panels. And then even once you have all of that installed, like, you need 5 times of it, at least, probably even more, to compare to what the output you get from a nuclear power plant. Mm-hmm. And just and then it's just the when that power needs to be consumed, because then you run into nuclear power's biggest economic flaw is that they generate so much power that if you're not capturing value from those electrons, then you're bleeding potential revenue. So if you can find a clever way to make sure that your price floor is set above zero, you can very significantly change the economic case for how nuclear power is generated and how it interacts with the grid, because now we can have a new option where we can sell to the grid, or we can sell through a digital conduit that can extract that value and make it available to anywhere in the world very, very quickly. Because a lot of the other technologies that they're talking about for doing that, and they're like great technologies, but they don't go to the same places that the Bitcoin miners can go. Like there's going to be lots of attention on hydrogen electrolyzers. There's lots of attention on desalination. There's a lot of excitement about the potential of doing synthetic fuels. So basically, you can do, if you can capture the molecules from the air, if you can capture carbon, nitrogen, oxygen, if you've got methane available to you, you can combine those into anything if you have the power to do it, which at the moment it is way too more costly than it's worth. It's more economical to just extract those hydrocarbons from the ground. But there is a time in the not too distant future when we have so much power available to us that we will be able to just synthetically create whatever hydrocarbons we want just from extracting the resources from the atmosphere. And I think that we're going to get there because Bitcoin mining is going to amplify the deployment of nuclear power much faster than we could have anticipated. Really, the only thing that's going to limit the deployment of these things is how quickly they can get built and configured. Like once they get to their commercial state and they start getting momentum, like Bitcoin mining is going to allow their order books to get a lot more filled up. They're going to have a lot more investor confidence because they know they're going to be getting those ROIs regardless of where we start deploying these things. But I'm probably getting a little ahead of myself and we can expose this a little bit more.
That was a nice natural segue to sort of the synergies between nuclear and Bitcoin that we certainly want to touch on. Just going back to something you said earlier, though, I'm curious, to me, like observing from afar, the big pushback to nuclear has been one, the cost, and then two, the safety. And you sort of alluded to the safety component there and how, for the most part, that might be more narrative driven than reality. So like, how do you yourself sort of handicap the obvious benefits of this, super dense form of energy versus the theoretical safety concerns or risks around, something going wrong? And that's, to your point, what everyone always sort of harkens back to is like, that's why we've sort of ignored this nuclear thing for so long, is because, something could go terribly wrong and make it all not worth it. So I guess maybe a little bit more color on the safety side of things, and then we can dive into the synergies with Bitcoin mining.
Yeah, like there's no denying, like working with radiation has its hazards and can be dangerous under the right circumstances. But like I mentioned earlier, it's an industrial hazard that we know how to manage, we know how to protect ourselves from. Time, distance, and shielding are the main three things that get stressed to everybody that works here. So if you are going to be exposed to any radiation whatsoever, you first want to limit the amount of time and then the distance, and put as much shielding as you can between you and that object. And sometimes you don't always have the option to have shielding, so you have to limit the other factors, and it really depends on the job that you're doing. So like I get exposed to, like in my job, maybe 1 millisievert of radiation a year, which is a modest amount for somebody that works in the industry. But then you guys, if you're traveling and flying, you probably get exposed to more radiation than I do. And I work with this stuff. Like someone actually did an experiment recently where they wore a dosimeter. They traveled all the way from America to Japan to go and tour and see the blown out reactor. And they flew all the way there, read their radiation readings while they were flying, and then it went back down, and then they got to the reactor, you'd see the radiation readings come back up. But in comparison, I got far more exposure to radiation from flying than they were standing 50 meters from a blown out nuclear reactor. So it's the hazard is just because of this poor understanding of radiation and the technology. it gets overly sensationalized when it happens, because Fukushima itself, it was actually a hydrogen explosion. Like, it technically wasn't a nuclear explosion. Like, what happened was they weren't able to cool it. Then they created a lot of heat within their pressure tubes, and then those pressure tubes, they release hydrogen, and then the hydrogen created the explosion once the pressure had exceeded what the containment dome could handle, and then it blew out the roof, and then that carries with it of small amounts of radiological material. So that was the major hazard that everyone was concerned with, which, when people go back and revisit that incident, there was far more casualties related to the evacuation than the actual event itself. And there's people that live within 100 meters of that site there. There's a 7-Eleven like right around the corner. Like, they give tour. It's a tourist site now more than anything, and I actually had the opportunity to tour one of the other reactor sites in Japan, where they showed us that they're turning those sites into fortresses. They've built 20-meter tall, 3-meter thick concrete walls around the entire facility, and they've put their backup generators on floating platforms. So if they ever get hit with another tsunami, those reactor sites will probably be the safest locations on the entire island. So they're not screwing around. They're putting a lot of money into this, and they are determined to get their nuclear reactor fleet back operating, because it's going to be greatly beneficial to the economics of their country that's already struggling in enough ways already. And yeah, and then just like CANDU, like the reactor type that I'm most familiar with, that's the Canadian one. Like, it was designed in such a way that it can't even melt down. Like, if there was an incident that would happen, there's multiple redundancy layers where it would just completely kill the reaction. It would drop the fuel rods, it would poison the reactor, and it would completely eliminate any reaction whatsoever if it started to get out of control, which it would be a costly incident, but it would also prevent any unintentional release of radiological materials should there ever be an event in a CANDU reactor. So they're actually touted as the safest reactor design on the market, and which is disappointing that we haven't continued to build anymore, but that may turn around in the not too distant future, because there's a contract with Romania to complete 2 of their reactors, because Romania actually owns 2 CANDU reactors, and they're planning on building another 2 that were started 20 something years ago, but then they kind of got put on the back burner during the contentiousness of the overthrow of the Ceausescu government. So that's kind of been set aside for a while, but now it's being financed and revisited, and there's at least a dozen other countries in Europe that are very eager to get into nuclear power, like, despite what Germany's objections to it might be. And then Germany's even an interesting case, because it turned out that the German Greens recently fraudulently submitted they manipulated the data in a report that they had submitted to a panel that was exploring whether or not Germany should keep or retire their nuclear reactor fleet. And it only just came out like 2 months ago that they had kind of played this shenanigans. But it also it also shows, like, being Bitcoiners, like, did nobody verify this? Like, you know that these people have vehement opposition to this technology. They came in with a report that says, yes, this technology, nuclear power, bad, shut it down, and nobody bothered to check their work. And then 3, 4 years later, someone checks their work and is like, they kind of lied here, guys, and we shouldn't have listened to them and shouldn't have gone ahead with this decision.
What's the response been there now that has come out?
There's a lot more politicians that are eagerly fighting to bring them back online, but part of their problem is there was such an eagerness to retire them that some have been decommissioned to a state where it's going to take minimum 2-3 years to bring them back operational. Like, they might be lucky, and the last ones that they brought down might be able to come back, but most of their fleet is pretty much mothballed, and it's going to take a lot of work to bring them back to life, which I'm sure most of Europe would be very happy if they did, because like, France is having to pick up the slack for basically everybody, because they're the ones with all the nuclear capacity. They had the foresight decades ago to make sure that they had everything that they needed to ensure their energy security in the future. But even then, France is having an interesting situation with some of their uranium mining sites throughout Africa, as many African nations at the moment are kind of trying to throw off that French boot that's been on them for many, many decades.
Mm-hmm.
So that is creating an interesting dynamic with France and their resources that they're typically used to having access to. So it's going to be interesting to see how that plays out going forward, because Africa is also very eager to get nuclear power. Like, I was just in Ghana for the conference the day that the COP conference was happening, and 20 countries pledged to expand nuclear power by 3x by the 2050s, and Ghana was one of the countries that had signed on to that. But then the other part that I see is that if America and Europe and Canada want to participate in the African markets, they're going to have to get their act together, because the Chinese and Russians are already eating our lunch. They've already been forming relationships. They've already got a lot of big plans. I just saw like something like Rosatom is going to be working with Vietnam to help them. They've got plans for floating nuclear barges for Guinea. There's Rosatom has been very, very busy building relationships throughout the world with nations that aren't overly concerned about what's happening in Ukraine. They just want a quality product that can just help them sustain themselves and give them a robust infrastructure that they can build their futures upon. So it's going to be interesting seeing how all of these dynamics play out as this market starts to mature. Because like once the SMRs start coming onto the market, we're going to see a lot more aggressive competition in getting these out there. Because especially if you've got like multiple different designs that are kind of competing in the same markets, there's going to be a few that probably don't ever even make it to that commercial state, because we won't need 4 different types of reactors that all are applying to the same like application, whether it's heat or like small off-grid scenarios. Like, we definitely want a few options, but we don't need 4 5-megawatt reactors. We need like 1 5-megawatt reactor. We don't need to explore too much of the molten salt reactors beyond just one design that's really, really capable of reprocessing it's like spent fuel and using recycled fuel as its primary fuel. Like, but there's that goes beyond like the American markets, the Russian markets, the Chinese markets. Everyone's trying to build these reactors and get them out onto the world market. So it is very, very exciting time in nuclear power right now. And like some of these companies are very aggressive aggressively trying to have something for the market by the 30s. And that's pretty optimistic at this point. But I think with the alignment of stakeholders and like policymakers right now that getting behind this, we've got a real chance to have some of these technologies ready for prime time within the next 5-6 years.
So that leads perfectly into what I was about to ask. Mentioned SMRs a few times. You mind defining, what an SMR is, how it changes, speed to build, and where these might be able to be, these reactors be able to be located? Maybe just dive in a bit over there.
Yeah, the SMR stands for the Small Modular Reactor. It's basically a catch-all for any reactor design that's under 300 megawatts. And the main idea is they want to be able to factory build the major components so that they can just quickly ship them to site and then have them commissioned in a very short time frame. Like the very, very small ones down in the 5-10 megawatt range, they're hoping that those can just be transported on a truck bed, dropped off on site, operating within 6 months. As they start getting bigger, that timeline starts expanding, but they're like hoping, like the idea is a 300 megawatt reactor will take about 2 years from shovels in the ground to commissioning. Like, and you'll have to have licensing and your site preparation. That will all be done long before shovels are in the ground, but that's all preliminary work. But once the sites have been approved and all the environmental assessments are done, they're hoping that these reactors can be stood up within like 2-3 years max, compared to the traditional reactors that we've seen come up. Like Vogel took like 15 years, and the one that they just finished in Norway took like 15 years or something. The one in the UK is at plus 10 years. So they've been lot of challenges getting these things built on time. So that is one of the appeals of the SMRs and the modularity component. And then the other appeal of the SMRs is that they're going to be using more novel fuel techniques. It's not stuff that hasn't been researched before, but they were kind of fuels and coolants that were put on the shelf decades ago when the whole industry as a whole kind of decided, like, we're familiar with these boiled water reactors. We're really good at the boiled water reactors and the pressurized water reactors. That's what most of the submarine fleet is based off of, that technology as well. So they were very familiar with it. So they went with that kind of standard design, and then that's what got built out. So like 90% of the reactors operating in the world are all based off of just boiling water under a pressurized condition, and then that just creates steam, turns a turbine. But these new reactors, they're getting into using molten salts as their coolants, sodium as their coolants, having like solid like graphite coolants and lead coolants. So they're exploring a lot of that have different passive features that they, like, if the reaction does start overheating, they've got features that it will start to reduce the how aggressive the reaction is, so it will actually slow itself down if it starts getting hot. So it has like a self-regulating mechanism in some of these reactors, so they'll require a lot less safety barriers. Like there's still going to need to be like an exclusion zone to varying degrees, but compared to like the many acres that the large reactors require, these small reactors are only going to need like a very small footprint of extra space around them to compensate for an accident, because they also have much smaller fuel loads, so they're going to have less of an impact should anything happen with them. But that the whole point of building these things is so that they have passive features, so that they can basically be walk away safe. If they lose power, they'll fail into a safe state. If they lose cooling, they'll fail into a safe state. So there's a lot of those cool features that they want to take advantage of. And then the other aspect of the SMRs that they want to use is, because of these different fuel types, is they can approach different temperatures. Because if you're only boiling water, your temperature outlet is limited to like boiled water, 100 degrees Celsius. If you pressurize that, you can push it up like to almost like 200 degrees Celsius. But these new reactors are hoping that some of them can have outlet temperatures as high as 800 degrees Celsius. So that can allow them to apply to a lot more industries and displace hydrocarbons in a lot of heat and steam applications, for like even just doing oil refining, textiles, like you name it. Like there's hundreds of different industries that you could probably think of that can use heat of that temperature. And like there's still a range above there that is going to be tough for nuclear to approach just yet. And like when we start getting up to 1,000 degrees Celsius, where it's still going to need things like coke coal that can really achieve those temperatures, or like very, very like high intensity like induction furnaces is another way to do that. But it just requires a lot of power to get there. And yeah, nuclear power is going to provide a new tool for a lot of these industries that have been pretty much dependent on hydrocarbons as their primary fuel source. Mm-hmm. And then the other thing I was thinking about beyond that is, like, you start displacing those hydrocarbons, they don't go away. They just start finding higher order uses for them. We start using methane more for fertilizer. We start doing what the heck's the word? Like the cracking process, where you can just recombine hydrocarbons and create longer chain hydrocarbons. We can do all kinds of stuff like that. We just primarily use a lot of that for our heat and electricity right now. So the idea was they would be less cost. They would cost less for those other uses if they're not being used for electricity and heat.
Whether you've been buying Bitcoin for years or just getting started on your journey, our multi-institution custody solution is the safest and easiest way to custody your Bitcoin. With Onramp and our partners at BitGo and CoinCover, you can sleep soundly at night knowing that your Bitcoin is safe from exchange failures, the loss of seed phrases, and broken hardware devices. Onramp's multi-institution custody solution eliminates any single point of failure, distributes counterparty risk, and minimizes required trust, all while providing greater assurances that a client's Bitcoin is secure and auditable on-chain. As a client of Onramp, your assets live in a multi-sig vault controlled by 3 distinct entities, none of which have unilateral control. Onramp provides products and services that honor our client's ownership and control of the underlying asset.
To learn more about multi-institution custody, check us out at onrampbitcoin.com.
Right. No, that's all super helpful context, and I think it's, at least in my mind, becoming clearer and clearer that people are having more of an open mind to nuclear, and I think it's, in large part a result of realizing that energy independence is actually vital going forward, particularly if you think about the build out of AI compute. You want to be able to service that in a way that is not reliant on other nations. And so I think people are coming around to the idea that energy independence is going to be extremely important going forward. And, in a parallel sort of narrative, I think people are realizing that Bitcoin is very important to become financially independent from the fiat system. And what I think less people are attuned to is that there's actually some synergies within both of those sort of parallel narratives that are emerging. So I would love to pull on that thread of why Bitcoin mining is a really perfect complement to the build out of these nuclear sites. And I think people have heard this concept with respect to the build out of wind and solar, but I think it's been less talked about in the scope of the build out of nuclear. So would love for you to drill down into why this is such a match made in heaven, if you will.
Well, I like to reference the pioneer species idea for stuff like this, because that's basically, like, Brandon created a brilliant analogy to like view this through. Like, you want to build power where you're going to need power in the future, but that you're not going to have sufficient demand for that power now. So Bitcoin miners allow you to plant that seed, build out that energy long before it's going to be needed, act as a placeholder until that market matures and invites more sophisticated energy buyers to come and participate in that market. Like, we kind of are already seeing inklings of it with what happened at the Susquehanna power plant where TeraWolf is. They built their little 48 megawatt mining load center, and then they started building a giant data center on the side, and then it got scooped up by AWS just a few weeks ago. And like, that's kind of like, yeah, that wouldn't have been there. That wouldn't have been already under construction had TeraWolf not already had the foresight to get in there and start doing that. And then we're like starting to see many of the other miners are starting to lean into it. And then there's also like many of the other nuclear reactor operators like Dominion Energy and Constellation. They're starting to have these thoughts too. They're like, they see these opportunities to bring in these large loads that can ensure that they're going to get a return on their product regardless of what's happening on the grid. Because like I had kind of mentioned earlier, like when nuclear reactors primarily generate their revenue by selling power onto the grid. Most of the time they'll sell it in like large tranches, but if they're exposed to like the day ahead market, they have to compete with like many of these other sources that get the production tax credits or just the renewable energy credits that the nuclear isn't as that aren't offered the same to nuclear. Like there are definitely some subsidies that come from nuclear, but not the same way. Of like, basically these windmills are paid to operate inefficiently and generate power when nobody needs it and the price is negative. But if they want to collect the PTC, they have to be on and pushing power onto the grid, even though the grid doesn't want it at the time. And it creates all these negative feedback dynamics where then your nuclear reactor is exposed to negative 6 cents a kilowatt hour, and they're like, well, we either now have to eat that loss or curtail their load, or the other option is like a policy decision where it's just like, well, they just get a guaranteed 6 cents a kilowatt hour regardless. Essentially, that's what we do in Ontario, is because often when we're at full capacity, we're paying the like Michigan and New York to take our surplus, because it is a liability on the grid if you start generating more than what your grid is capable of handling. And it creates these situations where the economics are not, it's not natural. The prices that we're seeing are so distorted by money that is not part of this market that it creates so much more challenges for the baseload generators to be able to be economic and actually sell their product and be good stewards of the grid. And then on the other side, like when we have the peaker plants, because they're only coming on for a short period of time during the year, they have to take advantage of like the worst grid prices of the year. So they're hoping for solar to just drop off so they can turn on for 10 minutes and scoop up like $3,000 per megawatt hour for an hour. And then that's their bread and butter. That's their World Series that they show up for just a few hours a year. And then that's how they make all that. But it's such an inefficient way to run a grid, but they need to be available because sometimes if you're heavily reliant on wind and solar, they could just go to zero. And now you have to have something available to fill that space. You can't just retire all of your spinning reserves and just say like, oh, we can handle it with batteries. Like, I'm really not impressed with what they're capable of just yet. Until there's a major breakthrough in energy storage, like what is available to the market right now is not capable of doing what they are saying that they want to do with like 20 hours, like 30 hours of battery backup. Like, that's a lot of resources.
Yep.
It's going to be very challenging.
I know, as Bitcoiners, we see, how Bitcoin can, and the Bitcoin miners can help facilitate some of these build outs of nuclear power plants. Curious, because you operate in both worlds, Bitcoin and the nuclear space. Like, in nuclear circles, does Bitcoin mining get talked about? Is there excitement there? As they absolutely have a vested interest in building out, some of these facilities. Does Bitcoin mining get talked about, or do we sort of get lumped in with AI? As far as a potential source for energy. How are we talked about over there?
It depends on what they've been exposed to. I deal with a lot of people that have seen the FUDs, like, but you're enabling criminals, but it uses bad energy, and then I look at them and it's like, you're in the nuclear sector, like we are the solution to that problem. And it's just all the typical FUD that we hear about it is, it's hard to overcome that anchoring bias. And then on top of that, I'm dealing with engineers. They're very smart people in their field, but they also went to university, and as you are aware, they were taught an economic framework that they were taught is economics. And so they have this complex where you start coming at them with Austrian ideas, and it's very off-putting for them. And so there's a bit of a challenge just getting this idea fully embraced by the people that need to hear it the most. Like, I'm getting some traction in some places where it's not as impactful, but then I'm starting to make some ground in other ways. But I also don't want to come off as being like so pushy. Then you come off as the crazy guy. But then things come around later, and then it's like, oh, the crazy guy was onto something. Like, because I know how you get very excited about learning about this technology, and you're just like, you can fix this, and you can fix this, and it's like, here's this very specific problem that we are working on, and that it was identified in a study that we did. What it was just like, because we did. They collaborated with the Ontario Power Generation and the mining company Morarco to build a hybrid energy study, and they've got a model that they use. They just pump in all the variables, but the one piece that I noticed that stood out to me was in the scenario where they wanted to deploy just nuclear. It clearly stated we cannot deploy just nuclear because of the high capital expenditures and the risk of leaving power stranded. I saw that, I was like, I have a solution for that. I will narrowly focus on just that one problem and offer a solution for just that singular focus. And they are very intent on, there's a very intent on hydrogen. There's a lot of interest in batteries. Like, I just saw that my company's building a battery farm that we want to absorb from the grid during the low power times, and then distribute it back during the higher power times. It's like, and I get that, and I get the logic to it, but I've got a much better solution than trying to arbitrage like power prices at different times of day. Just you plug in the computer and you turn it into money, and then you do whatever you want with it.
Yeah. Let's I would be curious, like, if you could sort of paint a picture for folks, and like, fast forward a decade, and we more fully embrace nuclear, we more fully embrace Bitcoin. What could a hybrid power system on a Bitcoin standard look like, and what would be the sort of key takeaways in your mind if you're sort of painting that picture 10 years out, let's say, or I don't even know if that's the right time frame, but into the future, if these sort of trends and trajectories continue in the way that we think they should, just from sort of like a economic reality perspective, what could that world look like in 10 or so years?
Well, like we're already starting to see the puzzle pieces come together. Like the Lightning architecture is an amazing payments channel, and seeing companies like Synoda starting to pop up that are going to enable consumers to pay their electricity, like literally stream in real time payments and settle that in real time. And then a friend of mine is working on a project that's kind of the opposite of Synoda. So if you're familiar with the programs where they have where they'll offer you like a rebate, but then they'll take control of your smart thermostat for the periods of time when the grid's stressed.
Mm-hmm.
His idea is more along the lines of creating like a bounty out of it and having a Lightning channel open between the utility and the consumer. And instead of just having unilateral control over their thermostat, they have to push a transaction, like a Lightning transaction, kind of like if you're familiar with LN bits and how that, like Ben Arc uses that to like turn on lights and gumball machines and electrocute Peter McCormick on stage. But yeah, Ovi had this idea. It's like, well, if you can turn things on, you can also turn things off. So he was like, well, if the utility were to pay consumers a bounty when they want them to curtail their energy consumption, that can almost create like a gamified structure where it creates a unique incentive for people to participate in these programs instead of just like opting in and then your thermostat just turns down on the hottest day of the year and you're like, okay, that's fine for 1 day, and then 2 days, and then 3 days, and then you start getting very irritable when you can't turn your thermostat before like lower than 75. And yeah, people will not be impressed if when that starts becoming involuntary. So he has an interesting idea of how to tie that together. And then you start thinking about how like the Lightning architecture, it's not a perfect map, but it does have similarities to how the electrical grid is managed, because it's just your generators, your substations, your consumers. There's nodes and channels. You got outbound nodes and inbound nodes. It's a similar idea, except you have to the flow is constant, as opposed to just having liquidity that can just be moved as needed. But I wouldn't put it past me if, as these generators start becoming Bitcoin miners themselves, then they'll start having Bitcoin mining on their balance sheet. They're going to have to start thinking about things like, well, could they provide Lightning liquidity and work with like Lightning service providers like Voltage to actually have these channels and actually put it to work for themselves. And then we're already seeing different ways, like Saylor's got his treasury strategy. It wouldn't be unfeasible if some of these companies start adopting similar ideas to keep just Bitcoin in their treasury. And like, even if they just want to just flip it for whatever currency they want as they're generating it, like that's going to give them they can just turn that into money right away. And then we are starting to see other products like the Luxor's hash price futures. So that's going to be an interesting one to overlay. So then they can just be like, okay, well, for 2 years we're just going to sell our whatever, like 1 exahash for whatever, and then they have that confidence that they're going to have their locked in prices. So that's going to be a lot more effective for utilities that are typically very risk averse for them to engage in Bitcoin. So if they can stabilize their revenue with something like a forwards product, then that's going to give them a lot more confidence. And then you start seeing how all this fits together, and like we could have like utilities in a microgrid essentially having like a Fediment with all of their customers, and then you can have these channels that have like the consumer pays through like Synoda's software backend, and then they have ways that they can receive money if they opt into curtailment programs, and then they can also have like if surplus revenue is being generated in these microgrids, they having a mint with all of their like local ratepayers, they can actually like send out like bonuses and very easily and quickly in that regard. And then it's all pretty much just going to get cycled into just building more infrastructure and just improving the systems and making them more robust and adding more equipment to them. And then like as the Bitcoin miners, they plant the seeds, and then you see more, you now have the option as higher order energy consumers come into those markets, now that they're more amenable to those larger consumers, because the Bitcoin miners go in where you need someone a little bit more robust and tolerant of tough conditions. So they'll set the stage so that the consumers that require a lot more like redundancies and a nicer, cleaner operations to be in these markets. So they'll start bringing them in, and then you have the option that you can then add more power, or you can take away Bitcoin mining, or you can do like a combination of the both. It's going to start giving them so much more optionality in how they engage with the financial markets. Like it was Bob Burnett was saying something like he expects like these Bitcoin miners and power companies and financial institutions to essentially kind of like all merge into singular entities. And based on the tools that we're seeing maturing and becoming available, it's really not out of the realm of possibility that these like power generating utilities will become like core components of the new financial rails on Bitcoin. So they're going to need to start having relationships with these financial institutions that are a little bit more familiar with that type of work, because there's going to be a lot of crossover in the coming years as these two start maturing into each other. Because I think we're only just getting started now that we're starting to see like the miners, the ASICs that are being custom built to the needs and wants of the actual like people in the industry doing this, instead of just having ASICs that are just 0 and 1 on and off. Now we've got like power throttling from anywhere from 0 to 1, and then overclocking if you've got them in immersion. So you can really push the limits on how fine of control we can play these curtailment games. Like that's like if you can wield megawatts within seconds, like that gets down to like frequency management, and like so that provides a lot of value to the grid beyond just being a consistent consumer of power. And it's going to give them a lot more certainty, a lot more stability, just a lot more confidence when we're trying to build out these projects. And it's just more projects, more orders, and then we just keep that feedback loop going, and then everybody's going to benefit in the long run if we can amplify these technologies.
Yeah, no, it's fascinating stuff, and to me, it's just becoming clearer and clearer. The more I've learned about it, and speaking with you, it's like, building out nuclear capacity is vital, I think, to our sort of energy independence going forward as a country. And I think, we mentioned this a couple of times, but like, I've heard quotes over the past few weeks of like, basically the energy capacity required for us to, remain competitive on the AI side of things, relative to the Chinas of the world. Like, we are going to need to build out immensely more capacity than we have in the US today. And so, if you believe that to be true, then like we have to lean into nuclear more than we already are. And as we've mentioned, like, Bitcoin mining is a great way to do that in the most efficient way possible. And so, to me, it's all lining up. And I think, it will take, the biggest, I guess, question mark is the political will to get it there, and for those regulatory hurdles to be softened, at least to the point where people can start putting meaningful capital behind the build out of these things. Is that, am I correct in that line of thinking? Like, is it the political will that's like the biggest impediment at this point in time?
Well, political will is definitely on our side now. Like in Canada, both conservatives and liberals are pro-nuclear. It seems like in the US, like if you got Senator Granholm coming out very, very pro-nuclear, and like I listened to that recent podcast that Trump did with the All-In guys, and he sounded very positive on nuclear. He was just like, we just got to figure out a better way to get these things financed, guys. Like, let's go. And like a lot of that is there is the bureaucratic momentum that needs to kind of be refined. So that is a challenge. Like, it just gets built up over the decades, and it's specifically designed for a unique type of reactor that doesn't align well with this whole new fleet that we're trying to bring into the world. So it's going to need some significant updates. And that's where I think some of these newcomers to getting into nuclear power are going to have an advantage, because they're not going to be bogged down by decades of bureaucracy that's just been piled on top of itself, and becomes more like of a kind of a suck for the money that comes into the industry. It all gets sucked into the licensing and the regulatory, and it becomes very challenging to actually do engineering and build these things because there's just so much like extra cost burdens on them. Yeah, where was I going with that?
I think we're cognizant of time. I know we're over an hour here, and want to be respectful of your time, Ryan. But any other sort of just further thoughts on because for me this has been fascinating in the sense that I think the sort of nuclear side of things is its own rabbit hole that I've begun to go down, and once you start to realize that there are some similarities to the Bitcoin rabbit hole, and that those holes actually potentially converge at a certain point, and there's a lot of interesting synergies there. It becomes that much more fascinating. So, any sort of final thoughts or final words on how people can learn more about this, where they can follow you, any of that would be helpful.
Well, the World Nuclear Association has a really, really good library of information for anybody that wants to dig in on learning about nuclear power. There's also the NEA SMR dashboard that was put out a few months ago. It covers the technological readiness on 6 different categories for 42 SMRs that are currently vying to get into the market. And so that's an interesting one. It explains a lot about the SMRs before getting into what is available on the market. And then just another one while I do still have you guys here, because I've been looking at these ideas, like, because I think about, I see the Bitcoin, I see the nuclear physics, and there's a few interesting similarities just with the principles of like radiation and nuclear physics and like Bitcoin, because like we're all familiar with the issuance formula and the halving cycle. Like that is exactly comes out of like radionuclides. Is they decay. The way that we measure how they decay over time is through their half-life. So how long does it take for half of that material to decay and become a new element? So it is interesting just kind of seeing that, like, because Satoshi seemed to be such a polymath in many different things, like it would not surprise me if he was familiar with nuclear physics and he was like, well, that seems like a pretty reasonable rate to model this issuance off. And then the other cool thing that I was even digging deeper into is when these atoms decay, there's a degree of, like, it's completely random. So no singular event affects another atom from decaying. And I got to thinking how that is kind of similar for how the Bitcoin miners are searching for a nonce, and just like every single hash is independent from every other single hash, but it's all completely random. But you can infer a pattern from it if you like kind of pull yourself back and observe it over time. So it's very interesting to see those relations that Bitcoin has to like the natural principles of nuclear radiation and how radionuclides work. I found that one kind of interesting, so I've been looking for an opportunity to share it somewhere, and just because
it's fascinating.
Like, yeah, and like I know like the Bitcoiners definitely like to see where our technology starts to cross over with other technologies, and see where these possible like where the hell did this guy think of all of these combinate, like, and the other, like the crazy one, I was just thinking about this the other day, like the 2016 for the difficulty adjustment, and we all know that's 6102 in reverse, but like that was such, like, what came first, because that actually at 10 minutes a block, that works out to be perfectly 14 days. So was it intentional, or was it just a complete coincidence? Because it's beautiful.
It is beautiful. It is beautiful. Bitcoin touches everything, and I think the themes and concepts we've discussed today really give me hope and optimism for an abundant future, and ideally one that's on a Bitcoin standard. So really want to thank you, Ryan, for coming on the pod and sharing your insight on these very interesting topics. Mitch, do you have anything else?
No, just appreciate the time. It's I agree. It's fascinating watching Bitcoin sort of submerge itself into every industry, and this power, and particularly the build outs of and the progress that we can make in the nuclear space. I learned a lot over here too. to seeing how both those two worlds can help each other.
Yeah, it's inevitable. I'm just trying to help it along any way I can because I don't know. I saw something that I think can help, but it's just educating everyone else is the challenge that I now find myself in. Which
no, and that's the key. It's people like you who have are sitting in the the other industry, whatever it may be, that see the light, see the vision of Bitcoin, and start making those connections. So we need more people like you, Ryan. Where can people follow you on Twitter?
Yeah, just Nuclear Bitcoiner on Twitter. I have Nostr as well. I should probably use it more often. But yeah, it's been a weird experience. Like I went from a guy just sitting in a lab, and now I'm talking on podcasts and just reach out cold calling to just random people that I think would like this idea. Like it all started with Foss of all people. Like he was the first one that I poked with this idea, and he's like, "That's a great idea. Here's another guy that's working on it. You guys should talk to each other." And then we submitted it to a contest, and then we won. And now I'm the Nuclear Bitcoiner talking about this stuff with everybody. Like the first big podcast I got invited on was McCormick invited me. He flew me all the way to Bedford, for God's sakes. I'm just like, there's much better people, but I was very honored to have been invited. Oh, speaking of McCormick, yeah, because I know we are for time. Like him taking over Bedford right now. I don't know if you've been watching this story with him fighting with the mayor and slowly taking over the city.
Yeah.
I think one day he's going to need a good, solid power source to keep that football empire he's going to be sustaining over there one day. So
100%.
Wouldn't put it past him to get some nuclear power in Bedford once we got Mayor Pete in the seat.
Yep. No, I see the vision. I see the vision. Well, thank you again, Ryan. This has been awesome. And
yes.
Yeah, thanks everyone for tuning in to this episode of Final Settlement, and we'll see you guys in a couple weeks. Later.
Yeah, thanks.
Thanks for listening to this week's episode of the show. If you found the information valuable, please share the episode with a friend or leave a rating on your favorite podcast app. All the links we discussed in today's show will be in the show notes inside your podcast app. Before we finish, a quick reminder that Onramp Media is for informational and entertainment purposes only, and nothing should be construed as investment or legal advice. Regardless of where you are on your Bitcoin journey, we'd love to hear from you. Visit onrampbitcoin.com/contact to schedule a consultation with one of our private client advisors.